Today we're going to be working on solving quadratic equations with all different types of methods. So the first one being factoring. So I'll be doing the odd ones, and then hopefully you guys can try out these even ones. So first thing to do when we're solving factoring is that we always want to make sure our quadratic function is set equal to 0. So you'll notice that the first two are set equal to 0, so that's less work for us. So by that point, we can actually start to factor. So to factor, looking at 16, we have 1 and 16, 2 and 8, 4 and 4. So factors of 16 that work to get us to -8 would be -4 and -4 to make -8. And if they are multiplied back together, they'll give us the positive 16 that we're looking for. So we're going to just rewrite your expression as x minus 4 and x minus 4 is equal to 0. Because there's a duplicate amount, we can say x minus 4 squared is equal to 0. Now, because it's already set equal to 0, what we can do is, if we want, because it's under a square, we can square root it. And what you do to one side, you can do to the other side. By that, we can say x minus 4 is equal to 0. You can actually just go ahead and skip that step and just take your parentheses or inside your parentheses and set it equal to 0. Because what we're going to be learning on later on is that this is a multiplicity and there's something unique going on at x is equal to 4. So with that being said, if x is equal to 4, this is your solution. So we can plug it back into your equation just to check your solutions. 4 squared minus 8 times 4 plus 16 is equal to 0. Or if you prefer, you can put it back into your factored form. 16 minus 32 plus 16 is equal to 0. So we get 32 minus 32 is equal to 0. 0 equals 0. So that is a true statement. So therefore, x is actually equal to 0. Now let's try it again with 3. So here we have a perfect square. So difference of squares. We can rewrite 49 to be 7 squared is equal to 0. From here, we can say we have a duplicate amount of your x's and your 7s. And in order to have no middle term, we can alternate signs. So we're going to rewrite this expression as x plus 7 and x minus 7 is equal to 0. We can then say x is equal to -7 and x is equal to +7. And we can do this just by setting them both equal to 0 and solving for x. So adding 7 to the other side, subtracting 7 to the other side, and that's where we're getting these two values. Again, if we plug them all the way back in, we should get a 0. So we have 7 squared minus 49 is equal to 0. So 49 minus 49 is equal to 0. So that works. And even if it were to be the -7, because it's all squared, that makes the negative go away. So we have 49 minus 49, 0. So that works as well. Now in your next ones, notice that they're not set equal to 0. So what we can do is actually bring all of your terms over to the other side. So a good rule of thumb is looking at your highest degree. If it's more than 1, we want the strategy of setting it equal to 0. So getting all of your terms to one side. We can do so by subtracting this 4k to the other side. So we'll get k squared minus 9k plus 18 is equal to 0. Factors of 18, 1 and 18, 2 and 9, 6 and 3, or 3 and 6. And of these factors, 3 and 6 can get us to a -9 if -6 and -3 are there. And if we multiply them back together, that'll get us to that positive 18. So we have k minus 3 and k minus 6 is equal to 0. So we can set them both equal to 0 by the 0 product property. And then we can add 3 to both sides. So we have k is equal to 3 and k is equal to 6. Again, we can check both into your original equation. so that we can see that they are completely balanced. Let's do it again here. So one thing we can, so there's a couple different ways we can do it. We can either bring your negative 3a over, but then we have to factor with a negative leading coefficient. So in that case, we would have to bring out your negative. It's not a requirement that you factor out the negative, but it does make it a lot easier to work with a leading coefficient that is positive. Or if you don't like that way, instead of bringing the 3a squared over, we can actually bring all of those terms over to the other side. So we have 3a squared plus 11a plus 6 is equal to 0. So then either of these options you are factoring with a positive leading coefficient. Now we always want to check for GCF. We weren't checking for GCF over here because there haven't been, but we still want to keep those good habits. So unfortunately, there still is no GCF. So that 3 is going to remain as your leading coefficient. So now we're going to be doing your AC method. So multiplying 3 times 6 to get us to 18. Factors of 18, 1 and 18, 2 and 9, 3 and 6. Of these factors, how can we get to 11a? Well, we can use 2 and 9. To get to a positive 11, we want to add 9 and add 2. And when we multiply them back together, we'll get a positive 18. Now, what we're going to be doing is we're just going to be rewriting this 11a as a 2a and a 9a. So we're using the factors that we broke it up with. We don't want to go in reverse and combine them back to 11a. We want to keep it expanded. The reason for that is now that there are 4 terms, we can go ahead and group. This is all still set equal to 0. And now we get to take out your GCF. Over here, we can take out a positive 3. Now, if we factored correctly, we should end up with the same parentheses. We should end up with a plus 3 and 3a plus 2. If we don't know how to factor, if our factoring skills are lacking, definitely go back and check out the 1.3 video. So now we have a plus 3 can be set equal to 0, and 3a plus 2 can be equal to 0. Subtract 3 to the other side. I should actually do this one at a time. So we have 3a is equal to negative 2, divide by 3. So we have a is equal to negative 3 and a is equal to negative 2 over 3. Now let's start again with number 9. So number 9, we want to bring all of your terms to one side, again, because your highest degree is not a degree of what? If it is a degree of 1, we're just using solving with linear equations. So it's just a quick process of that. So we have 5k squared plus minus 27k. We always want to write in descended order in order to keep with the quadratic equation. So checking for a GCF, what do we get? Unfortunately, no GCF, so we're going to have to multiply a times c here. So 5 times 28 for 140, and we're trying to figure out factors of 140 that can get us to 27. So we have 1 and 140, we have 2 and 70. Let's see, we have 3, no, 4 should work, 4 and 35. And keep in mind, we're trying to get to we want to get to 27. So we're getting a little bit closer. Let's see, 140 divided by 5 is 28. Let's see, 140 divided by 6 here. No, 140 divided by 7. So 7 and 20. And once we find it, then we can finish it up. So we can say 7 and 20. So as long as 7 minus 7 minus 20 is equal to negative 27. And when we multiply those factors back together, we get a positive 140. So we're going to break these two terms up into that, which we found, 5k squared minus, let me bring that down just a little bit, 5k squared minus 7k minus 20k plus 28 is equal to 0. We can take out a k, 5k minus 7. We can take out a negative because your leading coefficient here, if we group it, is negative, and I will show my little grouping sign. Now we have to figure out what we can take out. So we can take out a 4 from both. So that'll leave us with 5k, sign change, 7, our parentheses match. So left with k minus 4 and 5k minus 7. So we're going to do k minus 4 is equal to 0, 5k minus 7 is equal to 0. So k is equal to 4, and k is equal to 7 over 5. Now we'll continue on with the rest of this worksheet. We'll do it in parts. So this is just part 1 of, I believe, 4.